Hi everybody, my name is Fraser Kane. I'm the publisher of Universe Today, and this is your weekly space hangout for June 14th, 2012. So this week we've got the discovery or more information on the lakes on Titan. All you need to know about the upcoming Curiosity landing and the intriguing possibility that Earth worlds are more common and therefore there's more aliens. And so joining me this week, some combination of our regular team. I see we've got Amy Shira Teitel from Vintage Space. We've got Emily Lakdawalla from the Planetary Society. And we've got Nicole Gugliucci from CosmoQuest, a.k.a. the Nosy Sponge. Dr. Nicole Gugliucci. I've got to keep remembering that. All right. But before we get into that, just a reminder, an asteroid is going to swing right past the Earth today and not kill us all. So, for anyone who's wondering about this, there's an asteroid called 2012 LZ1, and it's going to be passing very close to the Earth, about 3.35 million miles away, which is about 14 times the distance between the Earth and the Moon. So not very close at all. In fact, recently we've had asteroids that have come within a fraction of the distance between the Earth and the Moon, and it's all still safe. So if you can see a lot of news about this event, it's very far away. That's pretty common, isn't it? 14 times the distance to the Earth of the Moon?
It's a big area. It's a really big volume, so yeah.
Yeah, that happens quite a bit. I mean, I know we get a couple every year that pass within the Earth and the Moon. We had one just a couple of months ago.
Yeah, that was cool because we actually saw that through the 26-inch telescope at University of Virginia, and we just like going across the fields. It was pretty cool.
Somebody sent me an image, and somebody said, I think I accidentally caught that asteroid going by, and I couldn't confirm it because there wasn't enough information in the photograph to try and sort of figure out the time and the placement, and it didn't seem like it was bright enough, but it shouldn't, the magnet bright. But yeah, and so you really got to know what you're looking for and have the right gear, but it should be naked eye visible, which is kind of neat. So. Cool. Cool. Okay. Well, let's get started then. So I'm going to start with Amy, which I know Emily's working on a little bit more prep here. But Amy, so you are covering the upcoming landing of Curiosity, which is not far away.
No, I think we're less than 8 weeks now, which is pretty exciting. So it's scheduled to land on August 5th, I think around 10 p.m. Pacific time. The SkyCrane, so Curiosity is using the SkyCrane landing system, but I won't go into the details, but the awesome system is using a back shell after the parachutes and everything. It's going to drop Curiosity onto the surface on its wheels. It's not actually going to land. So there's a lot of things that can go wrong in a landing like this, especially when you have the rover dangling on tethers below a back shell. Heavy winds, dust storms, all these things can just toss this rover right off course. So the way the mission scientists figure out where it's going to land is they pick the landing spot, and then they run a bunch of computer programs to figure out, with all the bad things that could possibly happen, where are all the possible points given its trajectory from the Earth to Mars and the way it enters and its sort of re-entry pattern, or entry pattern rather, where are all the points within its landing area that it could possibly touch down? And they create a scatter plot, and then they circle it, and then they make the error ellipse. So Curiosity's original landing ellipse is actually quite small. It's 12 miles wide and 16 miles long. I have... Oh, somebody's good at conversions. Unfortunately, I only have the Mars Phoenix lander as a reference, and it's 100 kilometers long and 19. Is anyone good at conversions out there?
Most of us think in kilometers anyway.
Yeah. I know. I'm used to sort of talking to Americans that need the imperial measurements for reference points. But so Curiosity's landing ellipse is already pretty small. But last week, the mission scientists actually made it smaller. It's 4 miles wide and 12 miles long. That's not a lot of room for error, for things to go wrong, especially with a really awesome and complicated landing system. So what this means for Curiosity? Curiosity is going to land in Gale Crater, which is I think it's 90 miles across crater. In the middle of this crater is a mountain. 18,000 feet tall. It's going to bring the rover to a landing significantly closer to this giant mountain, which is awesome because that's its end point, is to go investigate this mountain. It's made of stratified material, so it's supposed, scientists think that it actually has a really good record of different era on Mars. But it means that if there is a sudden gust of wind during the landing, it's unfortunately more likely to smash into the mountain. So that's the bad. The good is it shaves months off Curiosity's traverse to its first big scientific point. So kind of cool. Really hoping the SkyTrain works. I think it's such an awesome system, so I'm really excited to see what happens. And it's kind of neat. They have a lot of confidence in this system. This is a really tiny landing area for, you know, intergalactic gulf shot.
Now, you've got lots of plans for the actual landing, Emily, right? You've got big plans.
Yeah, well, my plan is to be having an anxiety attack up at JPL the day of the landing, whereas most of the rest of the Planetary Society staff are going to be at the Pasadena Convention Center hosting a big Planet Fest event with lots of awesome speakers, and we're hoping to have satellite Planet Fest events all over the world. So that's just beginning to come together, but we'll have the big the NASA TV feed on the big screen, watching all of the engineers pretending to have something to do while they look at their computers, when in reality it's all just happening on board the rover. I do want to correct one thing, though, that there's, of all of the things that could possibly go wrong during the landing, crashing into the mountain is not one of them. That landing ellipse is contains every possible location that the rover could land in. So it will land somewhere in that oval, and hopefully it will land safely. And that's what we're all going to be chewing our fingernails about on landing day.
What are the odds of a giant gust of wind that's bigger than anything they've predicted? 0?
Absolutely 0.
All right.
Yeah, I can confidently say that that is not going to happen.
What about those unit conversions we're struggling with?
That's right. Well, you know, if you think about it, at one point the Opportunity and Spirit landing ellipse was 160 kilometers long. And the reason that it was so long is because Spirit and Opportunity landed ballistically, and what that means is that they enter the top of the atmosphere like a cannonball, and they steer just about as well as a cannonball does, which is to say not at all. And so the wind could either the atmosphere might be thicker or thinner than they expected, the wind could take it a little bit, and so along the track of its entry, that's why the ellipse was so long and skinny, because just depending on that day's atmospheric conditions, it could fall short, it could fall long. And in fact, both of the rovers fell quite a bit long in their original landing ellipses. They'll land inside the ellipse, but it was long from the center point of the ellipse. From the very start, Curiosity has been very different because it does not enter ballistically. It steers. It's got, while it is in that sort of atmospheric entry with the flaming fireball happening as it's going through the atmosphere, it actually is, it uses rockets to steer out some of that atmospheric variability, and that's why its ellipse has been smaller from the beginning. It was about 25 kilometers long by 20. So it was always small. It was predicted that they were going to be able to get it smaller, but they didn't let the scientists imagine that it could get smaller. They forced the scientists to find a landing site that would admit that 25 by 20 kilometer ellipse. But now that they've picked it, now that they've launched, now that they know exactly what the trajectory is, they redid their simulations and they're able to shrink that ellipse, which means they can then shift its targeted location a little bit closer to the mountain that they are going to be trying to drive to.
And what do you think about, like, how much science you're going to be able to get? I mean, is that mountain going to be a huge boost on the science than just digging around in the dirt around the... I mean, based on what its mission is, I mean, isn't it going to be looking for, you know, not life, although, I mean, hopefully it'll find something like life, but it's going to be looking for, like, evidence of organic material in the soil. I mean, is a lot of that going to be found in the stratus of this rock? One
of the wonderful things about the Mars exploration program is how we've built and built and built and built upon what our understanding of Mars with better and better instruments. And between the time that we picked Spirit and Opportunity's landing site and the time that we picked Mars Science Laboratory's landing site, Curiosity rover landing site, we've had 2 orbiters, Mars Express and Mars Reconnaissance Orbiter, with amazing spectrometers that have found the sedimentary minerals that we've been looking for so very long. That indicate that are the kinds of things that you want to look at if you want to understand Mars's past at a time when there was more water around. We are certain that Curiosity is going to be investigating minerals that were laid down at a time when it was wetter in wetter environments. And one of the wonderful things about the mountain in Gale Crater is that Curiosity is going to be able to explore as any geologist would explore a mountain on Earth by going to the very bottom, seeing the very oldest rocks, and reading the story of Mars's history as it climbs very slowly upward through 5-kilometer thick pile of rocks. It's going to be an amazing mission. There are some important things that those of us who communicate about space exploration need to prepare the public for. One of them is that when Curiosity lands, it is not going to drive straight for the mountain. There is going to be a couple of months of Curiosity not driving very much, checking out all of its instruments, because it's the most complex landed mission that's ever been sent to the surface of another planet.
But that's boring.
I know, I mean, we joke about that, but it's
calibration.
really worrying, I think, to me, that the public is going to say, we sent this hugely expensive rover and it's doing nothing. It's just scratching the dirt. It's not driving anywhere. This must be a failure. And so I'm charging everybody to try to manage expectations about how fast Curiosity is going to drive. The view is going to be spectacular. No lander has ever been so close to anything so tall. So that's going to be exciting, but the view's not going to change very much for at the beginning.
So when will it get cool, do you think?
Well, for me, it's going to be cool from the start. But the driving, the nominal mission is 1 year long. They have to accomplish their mission goals within the first year. They estimated when they changed the position of the landing ellipse that they would cut 4 months off the drive to the base of the mountain, and that's a third of the nominal mission. So my guess is that we're talking about 3 to 4 months before we get to the base of the mountain, and then so during that time, I think the first month or two might be a little dull. After the excitement of the landing, then there's not going to be a lot happening. But after a month or two, they are really going to need to get on the road, and so we'll start seeing the terrain change after that.
Well, it's different than Spirit and Opportunity because it's got a nuclear reactor as its power source. It doesn't have the solar cells in the same way, so it's going to, I guess, however long that's going to take to run out of fuel, right?
Right, and so that's going to work pretty well for at least 14 years. Be careful, it's not a nuclear reactor, it's a radioisotope thermoelectric generator. There are no atoms being intentionally split.
It's an RTG, right?
It's an RTG. All that's happening there, it's incredibly low tech when you think about it. There's a pile of radioactive stuff that's decaying and throwing off heat, and we make electricity from that heat. That's all it is. There's no moving parts, there's no atom smashing or anything. It's just something hot make electricity, and that's it. One of the things, though, that the people think that the RTG is going to make it able to drive and do all kinds of stuff all year round with no regard to the weather, but a lot of the energy in the rover goes to warming the motors, because you have to warm them up so the lubricant can flow before they can drive. So it'll still be like Spirit and Opportunity. It'll have more activity during the summer than it does during the winter, but it won't have to park during the winter. That's one nice thing.
So, but it will actually be able to go for 14 years?
Yeah, well, it's not guaranteed for 14 years. It's warranted for 1 year, but
right.
Based on how well Spirit and Opportunity have been doing, sure. I mean, it's going to have power. I think we can be confident the RTG is going to work. It's a pretty simple device for 14 years. Now, whether its wheels are going to work that long is, I don't know, but we'll see.
That's really cool. All right, well, let's move on, Nicole, and then we're going to come back to you, Emily, because I know you've got a story as well about lakes on Titan. But Nicole, you've got a story you're tracking this week about the possibility that Earth-like worlds are more common.
So not just more common, but have been around for quite a while before Earth has been around. So our current model of star and planet formation is that you have this gas cloud that collapses in the interstellar medium. It forms a star in the center, and you have this disk of planets that forms around it. Now, whether or not you have enough rocky material to make the planets depends on when the star was formed in the age of the universe. So go back 13.6 billion years, all we have is hydrogen and helium in the universe. And so the first stars are very simple and boring and hydrogen, helium, and yay. And then those stars start making heavy elements in their cores through nuclear fusion, and then when they go supernova, they create even more. And so all this stuff we're made of, the carbon, oxygen, nitrogen. I mean, this is the origin of the quote, the Sagan quote, "We are star stuff." All that stuff comes from stars. So you have to have several generations of stars to build up enough of these heavier elements in order to make planets, basically. So there's this. So what these scientists did, I can put a link in the chat. Probably not now. Later. Is they studied a whole bunch of stars that have Kepler planet candidates around them. So they're looking at these smaller than Neptune. Some are possibly terrestrial-sized planets, and looking at their parent stars and how much heavy elements these stars have in them. So it's been known for a while that well, first of all, everybody compares how many heavy elements, or I'm going to say metals, the way old school astronomers use metals, which is everything other than hydrogen and helium. So if I say metals, that's what I mean. I'm sorry, it's antiquated vocabulary. But anyway, so the metallicity of the star is compared to that of the sun, because we know the sun made the planet Earth, so it had enough metals in it to make Earth-like planets. A lot of the Jupiter-sized and big gas giant planets, exoplanets, have been found, preferentially found around stars that have a solar metallicity or higher. But what they're finding with this new study that is published in Nature and was announced at the American Astronomical Society meeting in Anchorage this week, is that they looked at these stars that host small terrestrial planets, or at least the planet candidates from Kepler, and they tend to have lower metallicities. And so this means that the stars that can form rocky planets around them did so even earlier than the sun did. So the sun's 5 billion years old, could be 7 or 10 billion years ago that Earth-like planets, terrestrial planets, could have been forming. So what that does is that pushes back the amount of time over which you could have been forming terrestrial planets. And this is interesting for the question of, is there intelligent life in the galaxy? That means there's been a whole other 5 billion years or so of history that could have been forming life on terrestrial planets. And so this ties into the famous Drake equation, where we estimate how many planets may have formed life at some point in the past. We have no idea, but this is starting to get a handle on the types of planets that there are. And also ties into something called the Fermi paradox, which I love to talk about. I have a whole class designed around this. It's the question that Enrico Fermi and his colleagues were talking about over lunch one day in the 50s, is like, well, if the universe can create, planets and life so easily, where is everybody? They've had several billion years head start on us now. Why aren't we seeing them buzzing, and landing, and why isn't there like a federation or galactic empire already? And so this ties into that as well, is that there's now more of an opportunity over which, life should have been forming in the galaxy.
So it just makes the Fermi paradox more puzzling.
Yes. Yes.
So Nicole, where do you come down on the Fermi paradox?
I think that there's life everywhere in the galaxy. It seems like making life out of chemistry is not that hard to do, but the steps to get to a sentient, species of some sort it's not obvious that that's the way biological evolution is going to drive. So it may be that there's just lots of microbes everywhere and not so much thinking, communicating beings like us. Or if there are, they blew themselves to heck before they were able to travel the galaxy, which is sad. But it's
a great big universe and a great big galaxy with hundreds of billions of stars, and all you need is one. Right. And I've seen some really interesting calculations.
We haven't seen one. Yeah, that's
the thing. No, I understand that.
All you need is one.
We know we've seen one.
Yeah.
Maybe us, but that under the normal laws of physics, it should only take a couple of million years,
right? Exactly.
To fully colonize the entire galaxy.
Exactly.
With colonies. So you can imagine, just with probes going at 1/10 the speed of light, robotic probes, you send them planet to planet, and they self-replicate and send off to the next planet, and you should have that whole galaxy fully explored and fully colonized within a couple of million years. And what you're saying is that now we've had even more time, then that comes back to some pretty unsettling possibilities about what's going on with the Fermi paradox.
And I think it's been thought that, that this was possible, but this is actually data confirming that, yes, you can have rocky planets around these stars that are not so metal rich. And so, yes, you can push rocky planet formation further back than the origin of our Earth. And so this is actually putting concrete numbers and data behind it, which is really, really cool.
So what do you think about the idea of, have you heard of the Great Filter, I think it's called?
Is that like the galactic zoo hypothesis?
Well, just the theory that there's something that happens to all life when it hits some certain point, right? That that if we go and we go to the Mars and we find microbes on Mars that come with a completely different biological origin, then that tells us that not only is life common on Earth, but in fact it seems that life can originate separately in multiple locations. And also you've got the panspermia theory, where you've got life going from one planet to another planet in our solar system, and theoretically you could imagine life going from not only in our solar system, but we could be trailing biological material behind the solar system, and it could be getting scooped up and raining in on other planets in the
space is big. And
I know space is big, but the universe is old, and there's lots of time to do all kinds of crazy stuff. So you can kind of imagine that in fact life maybe is spreading from planet to planet, world to world, throughout the entire Milky Way. And so then it come again, where is the intelligent life? And so the thought is that there's some event that happens in the past, some kind of filter. The other possibility is just some event that happens in the future, some filter, right? Be it an ecological crisis or some, extraterrestrial filtering where they kind of come by and go, well, that's too much technology for you. Here come the berserkers to wipe you off the planet.
Captain Kirk, yeah,
Prime Directive.
The
Let's
Prime
hope
Directive
it's the Prime
doesn't
Directive.
work because of Kirk. Yeah.
So I'm just reading the comments. So Tim Hem mentions, he says, microbes on Mars is bad news. It means the filter is more likely in front of us than behind us. And so that's exactly it, right? Which is that if we don't
microbes on Mars that aren't like Earth microbes.
Well, that's exactly it. Yeah. So assuming that we find microbes on Mars.
Separately.
That's right. We find microbes on Mars and they don't have a common ancestor to us. That is a very bad sign.
Right. That means life is really easy to make, but that doesn't necessarily mean
life is really easy to make.
The jump from microbes to sentient beings is huge.
Well, but maybe. I mean,
Yeah, I think the biologists yell at us astronomers, and they're like, no, it's not that obvious that you're gonna get.
Martian rats that have no common ancestor to us is very bad news because that means that the filter, this thing, this event, is in front of us, not behind us. So.
Right. But if we see rats, not so much microbes.
Not so much microbes, right? So when they say we've discovered rats on Mars, that's when
That's
really bad. Yeah.
Interesting but bad.
Interesting but bad. Yeah. Yeah. So we want to meet we want to reach the technological level, and then we want all of the space aliens to go, welcome to the peaceful galactic community.
Yeah.
That's what
one
we
can
want.
hope.
One can hope.
I want to believe.
I want to believe, yeah. It's great. Really interesting stuff. I mean, the Fermi paradox is one of the most interesting kind of things to think about. I always like to think about time travel, like what are the chances of, if time travel, I always tell my kids, time travel will never be possible because there are no time travelers.
Is there like a version of the Fermi paradox for time travel? Is it like have a name
the
like
time
that?
traveler paradox? Yeah. I always imagine Hitler's bedroom would just be crammed up with time travelers. They'd be popping.
Episode.
Was it? Yeah, they'd be popping into his bathroom or something and just sort of filling up the rooms in Hitler's mansion with time travelers because they're all trying to go back.
Yeah, but the Time Lords would be preventing it.
They would be preventing it. Anyway, I'm totally off topic. I love the Fermi paradox, as you can probably tell. It is one of the. It is so interesting to me because it is such an interesting philosophical sort of puzzle, and I really enjoy it.
Whereas I file Fermi's paradox with Schrodinger's cat as things that make my brain hurt. Just give me a rock to look at.
Well, I like it when the brain is hurting. That's it. But yeah, looking at rocks are cool.
Rocks with rats and microbes.
Rocks with rats and microbes. And speaking of rocks, or in this case, liquid on Titan. So you had one last story for us, Sam.
Yeah, so there's a little news this week about a new paper published in Nature by Caitlin Griffith and several co-authors about tropical lakes on Titan. And when they say tropical, they mean in the sense of the tropics of Cancer and Capricorn, things that are in between those, closer, basically near equator lakes on Titan. These are not warm tropics. These are exceedingly cold tropics. The reason that tropical lakes are news is because all of the lakes that we've seen to date on Titan are in the poles. There's lots of them at the North Pole that we've seen with the radar. They're just beautiful. They have rivers emptying into them. There's a few in the South Pole, not as many as in the North. There's a few different hypotheses as to why that is. But mostly the equatorial regions on Titan have sand dunes. And so it was news when Caitlin Griffith gave a talk, I realized, at the Division of Planetary Sciences meeting in 2010, so this has been quite a long in coming, about these tropical lakes that she thinks she's seeing with the visual and infrared mapping spectrometer on the Cassini spacecraft orbiting Saturn. She points out these spaces. I've got a little, I'm going to screen share the figure from her paper. And so what you see here are 4 different observations with the visual and infrared mapping spectrometer, and mostly they look like, lots of bright different colors that mean very few things, but there's one spot on each one of these images that is black. And she argues that there's really nothing on Titan that could possibly be black at all wavelengths and all observations except for a surface of liquid methane. Now, it's weird that these things are at the tropics, and so she tried to come up with an analogy for that, and actually she didn't really have to go very far, because the analogy that's used for the sand dunes in the tropics on Titan are the Namibian sand dunes in Africa, which are these enormously tall, very long linear dunes that are aligned in the direction of the prevailing wind, because the prevailing wind blows east at one time of the year and west in the other time of the year, and that switching back and forth wind causes the sand dunes to make these long parallel cat scratches in the desert. And actually in the Namibian sand dunes there are places where when it rains you get small pools of water lying in the interdune areas in some regions between the dunes. And Caitlin showed that you only need methane about 1 meter deep or more than 1 meter deep in order to make these black reflective areas as seen by VIMS. So that's her argument. She says we're actually seeing wet spots in the equatorial regions of Titan. Now, it also makes sense because Cassini has observed methane rainstorms on Titan in the tropical regions as the seasons shift from summer in the southern hemisphere, which is what it was when Cassini arrived, through spring in the northern hemisphere, and now Cassini is going to be staying at Saturn through summer in the northern hemisphere. So an interesting article that the spot that I showed you on those VIMS observations were actually quite close to the Huygens landing site, and we know that Huygens traveled over places where there were dry riverbeds, and it landed in what looked like a dry lake bed with lots of rounded cobbles on it. So it's all forming a consistent story. I did notice in my coverage of the 2010 DPS meeting that after Caitlin gave her talk, another VIMS scientist named Jason Barnes stood up and said, this is very interesting, but I think you're wrong. And he didn't actually offer a whole lot of explanation, so I just sent him an email saying, do you still think she's wrong? And he sent an email saying that he had gotten a lot of flack for my writing about him saying she was wrong and he didn't want to comment. So probably there are people out there who think she's wrong. Titan's clouds and atmosphere is really hard to see through. The people working on VIMS have it really, really tough because the atmosphere contains methane, which is opaque at most infrared wavelengths, and so they're looking through what they call windows, which are regions of the electromagnetic spectrum where methane happens to be moderately but not perfectly transparent. And if you're trying to find methane lakes looking through an atmosphere of methane with a spectrometer, it's really hard. So I think she's done a good job of making a case for this. I think that as with everything else seen in optical wavelengths on Titan, it's tough to be convinced without corroborating evidence from another instrument.
Right, but I mean 5 years ago, her claim would have been outrageous to say that I think I've found lakes on Titan. But now, I mean, there's so much evidence of lakes in the polar regions of Titan to say that maybe there's also lakes in some of the tropical regions. That doesn't sound super extreme anymore.
No, especially not since we're pretty sure we saw a rainstorm that deposited, that darkened a region of the equatorial region of Titan, and which also then brightened over time, which they're still trying to explain. So we've certainly seen things that this is consistent with. So I think she's got a pretty good case now.
And is it possible that maybe this sort of puts maybe some constraints back on some of the polar lakes that have been discovered, because you're saying that in fact maybe they're not as deep and as extensive as people were originally thinking. I mean, when we think of a lake here on Earth, we think of this deep lake that you fish in, right? But you know, if even just a certain amount of wetting can create this dark region that's visible from space, maybe that's something that puts further constraints on the polar lakes.
The lakes we've seen in the poles have been observed with radar, and the radar is a wavelength. It's about, I want to say it's between 10 and 20 centimeters. I forget exactly what it is. But it can actually penetrate pretty deeply into methane lakes. And if you look at those lakes, you can see that close to the shore, you actually do get reflections off the bottom. They get lighter as you approach the shore. And so you can, you know, write down some models that give you some idea of probably how deep these things might be. And those things are actually quite deep. So what I think that one of the more exciting things about Caitlin's article is that it provides, it suggests that those sand dunes that are near Titan's equator might be hiding a lot of liquid methane very close to the surface. And that could help explain how there is so much methane in Titan's atmosphere. Because you put methane in an atmosphere, you bombard it with ultraviolet radiation from the sun, you break apart methane, and you make longer chain hydrocarbons, which is what all the orange gunk in Titan's atmosphere is. Methane does not last very long in an atmosphere. It gets broken down in a matter of tens of thousands of years, which is very fast, geologically speaking. So in order for Titan to have so much methane in its atmosphere now, you have to be replenishing it somehow. And Caitlin's wet dunes provide a good reservoir for a lot of methane to be lying around where it's actually kind of hard to see. If there are lakes between dunes, then you've got a lot of, I want to say groundwater, but it's not water, it's ground methane lurking underneath those sand dunes.
So I want to give people a chance now if they want to ask us any questions, comments. We've got a little bit more time, so you can either post a question that you've got in the Google Plus comment thread. If you're watching this on YouTube, you can also post a comment on the YouTube comments. And if you're watching this on the CosmoQuest website, or if you're using Twitter, you can use the hashtag Space Hangout, and I'll watch that. You don't need the CQX, just the Space Hangout.
Okay.
Yeah.
And no matter where you're watching it, be sure to +1 or thumbs up it so that we know that you're out there.
Yay.
We actually see the number of viewers now inside the Hangout.
Can I break in with a quick update on something?
Yeah.
NuSTAR launch. So I've been somewhat distracted chatting with my friend who is an astronomer at NASA Goddard. So I wanted to get the update from him. So this is my friend Dr. Dan Wick. We were grad students together at UVA, and he is a postdoc working on the NuSTAR. So that successfully launched yesterday? Yes, yesterday. And so he was giving me a little bit of insight of so he got front row seats from the control room at Goddard, and they were all nervous about it separating properly, and that the mast extends next Wednesday, at which point they'll actually be able to see whether it actually works. But so this is a high energy X-ray telescope, and everyone's calling it like the black hole telescope, because that's one thing to look for. But it is also looking for X-ray emission from massive galaxy clusters, so the largest gravitationally bound structures in the universe it's going to be studying as well, which is pretty cool. So I just wanted to pop that in really quickly. Yay NuSTAR, yay my friend Dan.
And it launched on a Pegasus, right? So it launched on one of those really cool air-based launch systems. So it's flown up on a carrier aircraft, and then it launches from beneath it and then flies off into space.
And then launches and it flies. I think it was at the end, and then 3 stages to get to orbit.
Yeah, there's a great series of images of that. Yeah.
I was reading an account of how that feels if you're inside the airplane, and they said that the rocket that they're dropping, it's very heavy, so the second that they drop it, they lose, I don't know, 20,000 kilograms or something, and so the plane pops in the air, and also the center of gravity shifts markedly to the back of the plane, so the plane's nose tips up markedly also, which is a good thing because that helps them avoid the thing that they dropped and is about to go boom and go into space. And so they ride that pop and lift, and they also bank at the same time in order to avoid the rocket shooting off. It's pretty exciting. I think that was on Spaceflight Now that I was reading that.
It sounds terrifying and awesome.
It sounds like fun to me.
Does it really? Do you ever hear about those researchers that fly their aircraft into hurricanes?
Yes.
And like, what? Can you imagine how like just normal turbulence? You know, you're like flying in an airplane and you get a little turbulence and you're sometimes like, oh, and you know, the rational part of your mind knows there's no risk at all. Turbulence has never taken the plane out. You can withstand anything, but still, it gives you the willies. But you know,
I love turbulence. I love watching how the pilots are responding. You know, the flaps in the elevators.
Do you like watching the wings kind of go up and down?
Yeah, I love it.
Love turbulence.
It's better than just sitting there being bored.
Yeah.
You should go and do. Have you done a zero-G flight yet, Emily?
Nobody has given me a ticket, and I can't afford one. So somebody out there wants to buy me a ticket.
Coming up in July, everybody.
Yeah. Space Adventures. If you're watching this, can you give Emily a free trip on the zero-G? Yeah. So getting some more questions left. Johnny Bo Anderson says, "I won't have any nails left the day the rover lands." So is that what you're feeling? You're going to be super nervous about how this is going to go?
I'm going to be having a total anxiety attack. I mean, I say that even though I have supreme confidence in the engineers. I was researching an article that I wrote for Sky and Tel about the landing, and I was surprised to learn, you know, the rover launched 2 years late because they weren't ready by the launch window. There was nothing about the landing mechanism that was unprepared for that launch window. They were ready in 2009. And so, you know, it's not to say that they're 100% confident that it's going to land, but they've done everything they can. They've tested everything they can. And they told the scientists they could land this thing anywhere on Mars. So for engineers, they are quite confident about the landing mechanism.
It feels to me like we finally have the real deal. Like, all of the previous landers and rovers have all been constrained scientifically, but this is just a monster. I mean, it is big, it's got tons of power, it's got lots of climbing ability, it's got tons of scientific instruments. I think it's going to make some really important discoveries, and that's why it just, at the same time, it feels like there's a lot of eggs in one basket, you know? It's the culmination of all of these missions, and yet it's so precious and has all of this sort of fancy science going on inside of it. I'm really nervous.
And, you know, it's a flagship mission with a flagship science team, and you know what happens when you throw 100 scientists into one room? They have 101 different opinions about what should happen with the rover. So this mission does not have a charismatic dictatorial leader like Steve Squires on the Spirit and Opportunity missions. John Grotzinger is the head of the science team. He's an incredibly nice guy, very good at figuring out the big picture, but he likes to lead by consensus. And it's going to be interesting to see if he's going to be able to make the scientists make decisions on what to do with the rover, or make executive decisions if the scientists just fail to come to a consensus, which is going to happen repeatedly. So that'll be an interesting process to watch.
And so someone's asking, is the Planet Fest going to be live streamed?
Yes. Yes, it will. Okay.
And we can talk about something to live stream it into Google Plus as well, so let me know.
Absolutely.
Something out.
And I'm sure I will do Hangouts and stuff from JPL, so I'll be doing that as well.
Yeah, well, you're just going to be busy. That's my only concern is you know, you're going to be so distracted and so focused as the actual.
You know, there's nothing to do until the thing actually lands, though. I mean, you have all this energy.
Well, I know. That's the point. That's what I think. We could just harness you, just, you know, opinionating and buzzing about it, and that maybe what that'll do is that'll be like therapy for you.
Or we can watch her have an anxiety attack.
Watch her have an anxiety attack. Yeah, live on camera. That might be news.
Oh God.
Yeah, we've got a doctor standing by. Right, so Todd Howard is wondering how the European ExoMars rover might complement the Curiosity rover science.
You know, the ExoMars rover has gone through so many different permutations and combinations. It still has too many instruments. They're going to have to throw off some instruments because it's not that big. They don't really have a launch vehicle right now. So it's really hard to say when and if ExoMars is going to be launched and what it's going to look like when it finally does launch. I hope that they make that 2018 launch window, but they got some more money to keep working on development through the rest of the year, but we'll just have to wait and see what shape that mission turns out to be.
Yeah. Well, and Todd Howard is mentioning that he hears ExoMars now won't have an RTG. So
I don't think it was never going to have an RTG. It would always be solar powered. The Europeans do not build RTGs.
They're not big fans. Well, they're big fans of nuclear power in Europe, so you'd think they would have stockpiles of radioactive materials that could be used for an RTG, but I guess maybe it's the wrong kind.
Yeah, they don't have the kind that you need to make an RTG. That's the only reason to make it, and they never developed RTGs. So
yeah, not that the Americans are going to have very many RTGs left either. I mean, they're out of them as well.
Yeah, we're out of plutonium as well.
Yeah.
Quick, make some supernovae.
Well, it's there. I mean, plutonium's there. It's a program to generate it, right? And there's all kinds of other reasons why you would use plutonium, which are bad. So,
but the kind that's used in RTGs is not the kind that's used in bombs. And furthermore, the process that you use to make it does not produce the kind that you use to make bombs. So there's no non-proliferation reason not to make it. Our inability to produce it has had to do with a territory fight between NASA, the DOE, and the Senate, either the Commerce Committee. I don't remember which committee. It's a ridiculously small amount of money that's needed for government in government terms. So like $20 million is needed to restart production. But there's a big fight in the Senate over who should pay for that, NASA, the DOE, or shared, and it just hasn't been resolved. I don't know. It seems to be moving forward a little bit more than it has been in past years, but we haven't started production again yet.
So if Iran got their nuclear program online and with the express purpose of only creating nuclear RTGs, nobody would have a problem with that? Everyone would understand that it was completely safe and only for scientific purposes?
I don't know enough about nuclear stuff to answer that one in an informative way.
Right. But no, I mean, it's that argument that, I mean, I agree. I think we should have lots of RTGs and you look at the kinds of programs that are going on that need them. I mean, the outer solar system exploration, some of these things where you're just not going to get enough high power. But even other stuff like places where you're not getting access to solar at all, like if you want to put a submarine onto Europa or you want to send some kind of rover onto Venus, you're just not going to get access to
or even to explore those permanently shadowed areas of the moon where we think there might be water hiding that astronauts can use. You can't do that with solar power. You have to have an RTG.
Yeah, yeah. And it's just the most efficient way. So, yeah, that is the future. So we need to get those back into program. That's no problem. So if anyone has any more questions, then feel free to mention them. We'll still be watching. Otherwise, I think we can probably wrap this up. Before you do leave us, though, where can people find out more about you, Emily?
At planetary.org/blog. Or just planetary.org. We have a lot more guest bloggers writing for us now, too.
Yeah, there's a bunch of bloggers there now. We should rope them into the Weekly Space Hangout. Mm-hmm. I'll pick your brain for some names. No, that's great. Thank you very much. So you feel free to leave when you need to.
All right.
Harville's the Skeptical is mentioning on YouTube that there is money in the latest NASA budget for plutonium-238 production. So maybe there are plans to get some RTGs back going.
I won't celebrate until production actually does get started again.
Or it's going to be used for some kind of, I don't know, some kind of like depleted uranium shells or something,
All right, bye, folks.
Poison bullets.
Bye.
Thanks, Emily. See you later. Cool. Okay. Well, I don't see any more questions. So then let's make sure everyone knows how to find more information about the people who are participating this week. So, Amy, where can people find out more about your work?
AmyShiraTeitel.com has all of my stuff, and my blog, Vintage Space, is there, and you can also find me on Google+, where I post loads of stuff. And
I think you've got an article on that you need to get some votes for today. So why don't we? Don't you have the 3 quarts?
Yes, it's the 3 quarts daily is the I'll put another link on it on Google Plus today, but my article is about the first launch delay that NASA really experienced. The manned program, which was Al Shepard's launch, he was supposed to launch in March. Wernher von Braun said, no, I'm worried my rocket's going to blow up and kill him, so let's do another monkey. It was Ham. We all know Ham was, bouncy ride but survived. The delay let Yuri Gagarin get in space first. So my article kind of traces that and kind of poses the question of what would have happened had Shepard launched on March 24th when he could have, as opposed to May 5th. So
the Americans would have had the first human in space? Yeah.
It would have still been suborbital. It was still a redstone. The Atlas was still very far from being man-rated, but would that have changed the space race? Would that have ended the space race? It's kind of, one German's very strong concerns about his rocket might have changed the entire shape of the 1960s. So,
I'm sure some author out there has written an alternate history about it.
I'm quite sure somebody has.
If not you.
Yeah, maybe that's
work on
my next project.
Your new science fiction alternate history novel.
Yeah. So that's online at the Three Quarks Daily voting site.
Cool.
Perfect. And Nicole.
Yeah, noisyastronomer.com. You can, all the stuff I do is there. But please do go to cosmoquest.org and come join us on the Moon Mappers project and learning about science and actually doing science.
That moon isn't mapping itself.
It's not mapping itself, man. We have so many craters.
Yeah.
So.
Well, didn't we? I know we ran out of craters for people.
No, we
to
ran
map
out
them.
of ice investigators images, but now we got new ones.
We got new ones.
We're also looking for Kuiper Belt objects for the New Horizons probe to actually visit. It's on its way to Pluto and beyond. So we need your help discovering.
Yeah. So if you like space or like science and you want to do science, then you can come to cosmoquest.org, and we've got a bunch of really cool programs that you can work on. One to help us map craters on the moon, another to help us find future targets for the New Horizons spacecraft. Mm-hmm. This is real science. This is real collaboration with researchers, and the work that people are doing is actually getting incorporated into their research projects. So
yeah, it's great.
And it's like a video game.
And I'm actually relearning planetary science. It's really fun.
It's a great, and again, if you have any interest in going into science as a career path, going into planetary geology, things like that as a career path, this is the kind of work that you'll do. So, you can get a chance to try this out.
There aren't enough grad students.
There aren't enough grad students, yeah. So if, after 10 years of study and you become a grad student, then you can do this work. Or you can do it with us. Yeah. Real easy. And then you can decide whether or not this is the kind of work that you want to do for the rest of your life.
If you're crazy enough.
If you're crazy enough, yeah. And of course, you can find out more about me at universetoday.com, or you can listen to the weekly podcast that I do with Dr. Pamela Gay called Astronomy Cast. So the next thing we're going to be doing, I guess, is going to be our virtual star party, where we connect a bunch of telescopes live into a Google Plus Hangout, and that's going to be on Sunday night. I don't know, June. We start whenever it gets dark on the West Coast. So usually it's around 9 Pacific. We're reaching the summer solstice now, so now the start times are going to get earlier and earlier. So in the wintertime, we start around 5 Pacific, and in the wintertime, in the summertime, it's more like 9:30 Pacific. So the downside of living
is the reason for the season.
Awesome. All right, well, thanks for joining, guys. Really appreciate it. And thanks to everyone for watching us, and we'll see you all next week.